Okay, this one is a math problem that has cropped up in a physics course. We just have to substitute this expression for x and this expression for f, which appears in our expression for x, into the given differential equation and show that it leads to an identity. In that differential equation we have x, which can go straight in, and we've got the second derivative of x. So let's get started by taking the second derivative of x. And f is just a constant. It'll be easier to take the second derivative before making the substitution. There's x, dx by dt. Okay, I got a constant out front, so that just stays there. And then times the derivative of the cosine with respect to its argument, which is minus the sine. And then times the derivative of the inside. We're using the chain rule for the function of a function. We've got the function is the cosine of y, where y itself is 2 pi ft, a function of t, the variable with respect to which we're taking the derivative. And so we got the derivative of the cosine with respect to its argument, and then times the derivative of the function that's inside, which is just going to be 2 pi f. And I'll simplify that a little bit. Dx by dt can then be written as 2 pi f times a. I'll take that minus sign out front. Times, and there's the sine of that 2 pi ft. So I got this covered right there, the 2 pi f I brought out front. The a is right there, and the minus sign is right there. Got everything. Alright. Then the second derivative. Same thing. I got a big constant out front this time. Minus 2 pi fa. So I just copy that. And then times the derivative of the sine with respect to its argument, which is just the cosine. And then times the derivative of the argument of the sine with respect to t, which would be the 2 pi f. So I've got the second derivative is, I got a 2 pi f there and a 2 pi f there. Multiply them together. I've got, I'll call it 4 pi squared f. Is that going to be handy? Let's leave it as minus a 2 pi squared times an f squared times a times the cosine of 2 pi ft. I was looking up there to see when I made the substitution for f what would be canceling, and I see that 2 pi over there. Alright, so now I want to substitute this expression for f into our expression for x, and then into our expression for the second derivative of x with respect to t. For the case of x, we wind up with a, so x is equal to a times the cosine of 2 pi times 1 over 2 pi square root of k over m times t. And the 2 pi's cancel, so x, I think I'll write that down here. X is equal to a times the square root of, times the cosine of the square root of k over m times t. That's quantity K over M under the radical. And that product is what we're taking the cosine of. So I think I've got that. Alright. And then if I substitute that expression for F, that same one, into my expression for d squared x by dt squared, that second derivative of x with respect to t, I get for that one d squared x by dt squared is minus, I get two places to substitute it in that expression, minus 2 pi squared times, now f squared is going to be 1 over 2 pi squared times k over m. That's f squared right there. And then I got the times a and the times the cosine, see if I got any room over here, not much, of 2 pi times 1 over 2 pi times the square root of k over m. And then outside of that, I've got a t. Alright, so d squared x by dt squared is equal to, well, let's see, I get these 2 pi squared canceling out. The 2 pi cancels out there, and I'm left with minus k over m times a times the cosine. That was the cosine of all of this stuff. That t is disappearing on the inside, so I'll write it quickly. It's the cosine of square root of k over m times t. And yeah, that's what we had up there. And we're supposed to substitute both of those into this expression right here. And see if that leads to an identity. Alrighty, let's do it. Where the x appears, I'm going to go ahead and write minus k times the x right there. That's a times the cosine of the square root of k over m times t. Now that's supposed to be equal to m times minus km a cosine of the square root of k over m times t. And let's see, I'll go ahead and cancel out the m's there. On this side I get minus ka times the cosine of root k over m times t. That's equal to minus k times a cosine square root of k over m times t. I've got the same thing on both sides, so this is an identity. I mean, the exact same expression. Ident t. Because we've got the same exact expression on both sides. Thus, indeed, x equal a cosine of 2 pi over f, cosine of 2 pi ft, with f being equal to 1 over 2 pi times the square root of k over m, is indeed a solution, as we plugged it in and it led to an identity. So that does it for SIC 3.